So now let's look at how we measure variability in quantitative data. So we've been looking at histograms and we've been looking at our dot plots, and we can see that there's variability in the data. So how do we summarize the fact that every single response isn't the same? Everybody's hand width isn't identical. So let's assume we have the following data set. So here is a bunch of numbers. One of the ways we could summarize this particular data set here is we could look at the range. So the range is the largest value minus the smallest value. So we would take 49, the highest number, subtract 6, the lowest number, and the range is 43. So we can say that whatever this variable is, that this spread from highest to lowest goes 43. So if we're comparing different data sets, we're comparing, let's say that this is age for our, I'm stuck as to an example. Brain fart. Okay, so let's say that this is age of people who work at McDonald's, and then we have another data set, age of people who work at Tim Hortons. Okay, so what we could do is we could look at how much variability is there in the age of people who work at McDonald's. And maybe that range is a 43-year difference. We have a 6-year-old working and a 49-year-old working. And then at Tim Hortons, maybe that range is only 20. Maybe it goes from 20 to 40. Minimum 20, maximum 20. So we could then compare how much variability there is in one group, the people work at McDonald's, versus the second group, people work at Tim Hortons. So we can summarize these samples with the range by looking at the two extremes, high and low. It's the very simplest method of dispersion, so quick and dirty. The challenge, of course, is going to be highly impacted by who's in your sample. It's sensitive to extreme values. So if you randomly grab someone who's younger or older in the sample, and maybe that's not actually representative of the greater population, it's going to be highly skewed in terms of it's going to say things about the population that may not be accurate or representative. So we use it as a quick method to understand, but in terms of that greater knowledge and inference we want to make about the greater population, we'll tend to avoid it and use things like the standard deviation. The next one we can look at is what is called the interquartile range. The interquartile range gives us the middle 50% of the data. So the benefit of the interquartile range over the range itself is that the interquartile range is going to be less impacted by outliers. So if the data is skewed, if we have really high numbers or really low numbers, with the interquartile range, we recognize them only as a large data point, not as how big the number is, or a small data point, but not how small the data point is. So it's going to be a lot more stable. If we're taking sample after sample, it's going to change less than the range, which is going to be highly sensitive to whether or not you grab that extreme person, right? That low age or high age. Less affected by outliers than the range. It's also going to be less affected by outliers than the standard deviation. When we have ordinal data, like rankings, like strongly agree, strongly disagree, then the interquartile range is a good measure of variability for ordinal data. So we're talking about percentiles. It is the middle 50% by taking the third quartile and the first quartile. So what that means is the first quartile is the point at which 25% of the data is below it, and the third quartile is the point at which 25% of the data is above, or 75% is below. So just like the median, you got to take your data, put it in order from smallest to largest, and instead of finding the number in the middle, you find the number that is the first fourth, and you find the number that is where the last fourth starts. So let's look at an example here. So let's take this data where it went from 6 to 49. We would have to sort it, 6, 7, 15, 36, 39, all the way to 49. The first quartile is going to be where 25% of the data is below. So first we have to do is figure out how many data points do we have. We have 2, 4, 6, 8, 10, 11. Okay, so we have 11 data points, which means that to find the 25%, we would take that 11, add 1, get 12, and then we want to take 1/4 of that. So 1/4 of that is 3, which means the 1, 2, third number is going to be the first quartile. To find the middle, that's the median, Q2, the second quartile, 50% above, 50% below. Well, we already know we would take the 11 and we would find the middle one where there's 5 above and 5 below. To do the calculation this way, you would take the 11 points, add 1, you get 12, half of 12 is 6, and so that would give us this point where there's 5 below and 5 above. Okay, so here's our median, that's Q2. Here's our first quartile, that's Q1. And then our third quartile we would find, we're looking for the point at which 25% is above, 75% is below. So you would take the number of points, here's 11 points, we add 1 to it, so we get 12, and we find 75% of that, which is 9. So that means 1, 2, 3, 4, 5, 6, 7, 8, 9. The third quartile is 43. So if we're to find the interquartile range, it's 43 minus 15, and the middle 50% spreads 28 points here. Okay? Now, if you're doing all this in Excel, I'm just building a new one here. I don't know what these numbers are, so let me just write them down here. 6, 47, 40, oops, let's not do that, right on top of it. 6, 47, 49, 15, 42, 41, 7, 39, 43, 40, 36. So in Excel, we can have it find us the mode. Okay, I'm just going to go back up, make this bigger. Can't change the size of it while it's inside a cell. Let's try this again. Okay, so we could take this information and we could find the mode, the most common number. Okay. It's going to complain because there is no repeats, right? So there is no mode. All right, median. Q2 is 40. And we can find the mean of this data set as well. In Excel, it's not mean, it's average. Okay, so if you want to find the average, let's just write this out. There is no mode because there's no most common. The median is 40, that's Q2. Okay. We could then find the range. To find the range in Excel, it's max minus min. So we would do equals max, highlight the data, find me the largest number, subtract the minimum number. Okay, and we get the range. Okay, now we want to find the interquartile range in Excel. To find the interquartile range in Excel, there's not a command for interquartile range by itself, but you can ask for Q1 and Q3. So to do this, equals, and then we want quartile. We'll just use the old version here, quartile. And then what you do is you highlight your data. And then you tell it, I want quartile 1. So notice it shows up and it gives you first quartile, median value, third quartile, maximum value. So we could have used this quartile to find both the max and the min for the range, as well as to find the median instead of equals median. So you can also use this command to get that. But here we just want Q1 and, nope, not median. We want quartile and data. And then we want quartile 3. So to get the interquartile range, we want to take Q3 minus Q1 to get that range of values. Okay, so in Excel, we can get the mean, the median, and the mode. And of course, the mode is not going to give you anything if there's no repeat numbers. And then you can get the range, max minus min, and you can get the interquartile range, that median, that middle 50% as well. So let's just take this data, and I'm going to then, let's show you here where I am going to make this number change. So you can see here when I make that number lower, the mean gets pulled down. The range is going to get bigger, right? It's going to go from 43 to, whoops, redo. It's going to go from 43 to 48, but notice how the interquartile range didn't change, right? It is still 17, whether I make this 1 or 6. So it is less impacted by the size of the outlier than the mean and the range. And you can see the median also didn't change, right, as I changed this back and forth. So interquartile range is often used to describe variability when we're using the median as the measure of central tendency. And we'll use the range, but we recognize that it is impacted by those extreme values. And for each time you take a sample, you're going to get something different. So range is talked about, but interquartile range is more valuable. All right, let's go back. Okay, so we have looked at range and interquartile range. We could get different percentiles. It doesn't have to be a quartile. You could find the 12% instead of the quartiles, but the interquartile range is set at 25% and 75%, but you could find percentiles if you wanted to. And this would be the formula for doing that to find that percentile. We won't worry about that. Now, if we're doing a quick summary of data, we can do what's called a 5-number summary. A 5-number summary will take the minimum and the maximum, okay? And if you subtract the two, you get the range. It'll take quartile 1 and quartile 3, because if you subtract those, you get the interquartile range, and it will have the median. So at a quick glance, if we didn't have that histogram or dot plot to describe the data, you can get a lot of information simply from this 5-number summary. We know the middle is 40. We know the middle 50% is between 15 and 43. We know the extremes are 6 and 49. So you can do a quick 5-number summary to help you understand the data. Typically, you would combine that with the mean and standard deviation to get that full picture of what's happening, because once you compare the median and the mean, you can start to see that skewness, as well as we have our extremes, so we can see the outliers as well. So examples of 5-number summaries, here's that hand span between males and females. If you're comparing the male and female students, you can see here that the median is lower for the female students. You can see that there are some extremes here for the female students at 12.5 compared to the lowest number for males is at 18. And you can see even that the middle 50% for males starts at 21.5 and the middle 50% for females is below that. So that middle 50% for males is, and they don't even overlap, is what I'm saying, in terms of that distribution between male and female hand sizes. Okay. We can summarize variability with a box plot. So a box plot requires us to have those quartiles, first and third quartile. I don't know why I have second quartile written here, because the second quartile is the median. So we would put the first quartile, the median, which is the second quartile, and then the third quartile on our box plot. Our box plot also shows outliers. So let's see if we got a picture of a box plot. Here's a box plot here. So the way this works, also called a box and whisker plot, shows here that the points that are here are outliers. Okay, they're outside of the majority of the data. Here we have Q2, this line in the middle of the box is the median. The box itself is the interquartile range, so Q1 to Q3. So the middle 50% fall within this box. Okay, then we have our whiskers. Our whiskers take our Q1 and go 1.5 times the interquartile range, and then it takes Q3 and adds 1.5 times the interquartile range. So this should cover the majority of the data. Anything outside of that is seen as an extreme value and identified as a little star here as an outlier. So in this particular data set, the smallest data falls within 1.5 times the interquartile range of Q1. But then we have ones that are really large values that are outside or that are outliers. So to create this, we need Q1, Q2, Q3, and then the whiskers are based on that difference between Q1 and Q3 times 1.5. So if you're going to create a box plot, you can create them inside of Excel. Let's go find my data here. So if this is our data here, we can create a box plot. It's called box and whiskers. And you can see here our box and whiskers. And you'll notice the line's a little hard to see, but this is the median. And here's Q1 and here's Q3. So because this is not in the center, the median is not in the center, that's telling you have more extreme upper values. But they're not so extreme that they're more than 1.5 times the interquartile range more than Q3. So they're not outliers here. Now, if we go back to our hand height data set, let's get rid of this. Then what we can do here is we can have it create for hand span, go insert, and where you found the histogram, you'll find the box and whisker. Okay. And there you can see the hand span here. We could also separate out the data for male and female separately and look at the different box plots. So let's just do that. Let's just do a quick sort here. So insert, sort. I'm going to sort female here. So let's take our hand spans for females. I'm just going to copy that. Here's female. And I'm going to take the one for male. Okay. So male, female. Okay, and highlight all that. And let's insert, our box and whiskers. And so you can see here the male and female, and I'm just going to format the axes by changing the lower to, let's say, 15, just so we can see it better. Okay, so by doing that, what you can see is how male and female compare. So notice that the median is lower for female than male. Notice, as we talked about before, the boxes don't even overlap. The interquartile range for female is below that for male. So you can see how these two groups compare with our box plot. We can also see how much the variability is. Notice the size of the boxes. If the two boxes are about the same, then the variability in both the male and the female sample are equivalent, even if their hand span is not. If you do have, let's say, one big box and another one has a little box, then there's way more variability in one group than another. Okay, so one group is not that different from each other, and one group has a lot of differences within its own group. So maybe there's subgroups there, or a lot of more homogeneity in one group. They're very much alike versus the group that is not. So we can start to ask questions about the data based on what we are observing. So we can create box and whisker plots or box plots in Excel, right? Insert, and then it's the same place you found the histogram, box and whisker. You can create it that way, and you can compare multiple groups like we did here. You just need it as 2 columns, one for each group, in order for it to create those for you.